Good morning, Biology 30s. So we're back at our Population Genetics Notes Guide Part 3. This is our Hardy-Weinberg equilibrium. We've done a couple of examples, and I wanted to show you one that is just a little bit different than the others. So here's example 3, and it has a population given to us, and it also tells us a certain percentage of the people have blonde hair. And then it goes on to say that blonde is recessive. So, in other words, they're telling us that this is a recessive trait. Now, what's different about this question is they're asking how many people are carriers, in other words, heterozygous for this recessive trait. They carry the recessive allele for blonde hair. So a little bit different, but let's do it the same way that we've always been doing. And that is to start by setting up with our two equations. So we've got our alleles formula, P plus Q is 1. And what does that mean? Well, the P refers to everybody in our population in Strathmore who have a dominant allele for not blonde hair. And Q is everybody in our population that has the recessive allele for blonde hair. Okay, so we've got our alleles formula, and then we're going to write our genotypes formula. And again, if you forget these, they're in your data booklet. So we've got P squared plus 2PQ plus Q squared is 1. And that's our Hardy-Weinberg equation. And everybody in our population who would be homozygous dominant, who'd have two copies of the dominant allele, that's our P squared term. Heterozygous have a dominant and a recessive allele, so they're heterozygous. And then Q squared is our homozygous recessive. So what we've been given here is a trait, right? It's blonde hair, and it's 37% of the population. Only for the recessive trait can we say, this doesn't work for the dominant. If they had brown hair or if they had a different hair color, we wouldn't know if they were homozygous dominant or heterozygous. But because they have the recessive trait, we actually know that they are homozygous recessive. They must have two recessive alleles. So we can actually say this is our Q squared value. And then from there, we just proceed normally. We've done a couple of example questions like this where we are asked for the allele frequencies and then the genotype frequencies. So same thing is we're going to go through, and Q squared, we'll take the square root to find Q, use our allele formula, P plus Q is 1, rearrange that to solve for P. And then the only frequency that they want for the genotype is our carriers, and our carriers are heterozygous. That's our 2PQ term. So we're just going to do this normally, and then the twist comes right at the end of the question. So we've got 37%. In other words, we've got Q is 0.37. We're going to take the square root of that on our calculators. This is the value we get. P plus Q is 1, so great. 1 minus that is this value. And then those heterozygous individuals, that is our carriers of this particular trait, this blonde hair. And so we just go 2 times what we know for our P value, just figure that out, times our Q value. And so here's our 2PQ. Now, here's what's different. So they're actually looking for the number of people, okay? And that's why we've been given a population at the beginning. And so here, normally we would just say it's like 0.477 or 47.7% of the population, but this is a little bit different because now we are asking the number of people. So we have to use this people in the population, 11,104, and multiply our probability by that. And so when we do that, we get 5291.6. So you can't have a 0.6 of a person. So we're just going to round this, just round it like you normally do with numbers. So the 6 makes the 1 round up to a 2. And so we've got 5292 people are carriers. That's our 2PQ term. That's the individuals that are heterozygous in this population. Okay, so that was just a little different twist, but it's, we figured it out the same way that we have all of our other questions. Okay, so next we had some practice problems. And again, same thing, write out your allele and your genotypes. And then once you've got them done, here's a really important clue to figure out how do you approach these questions. So you got to ask yourself, what am I given in the question? Have they given me a trait, a phenotype, what something looks like, its appearance or its physical characteristics? Then, if it is a trait, is it the recessive trait? Because if you know the recessive trait, you also then know that's the recessive genotype, and that's the Q squared. And then, of course, we know that if you find the Q squared, we've been doing this for a couple of questions. You can then find Q, you take the square root, and then use your equation P plus Q equals 1 to find P. And then from there, you can figure out whatever they want. Do they want P squared? Do they want the carriers, the 2PQ, the heterozygous? Do they want the Q squared? Or maybe that was given in the question, right? You can figure it out from there. Okay, so here's an example where it says, here's a recessive trait. Okay, well, a recessive trait was 300 out of 1,200 people. So the recessive trait, well, that's our Q squared, right? Because if it's the recessive trait, they have to have 2 copies of the recessive allele. That means they have the recessive genotype. So back to our squirrels example, that's those squirrels that were little b, little b. And so understanding that if the individual has a recessive trait, then they are the Q squared term. And from there, you can just work the question out as we have done. Okay, so reading really carefully. Now, what if it doesn't say that? What if it says there that it is a certain allele frequency? Here's an example. The recessive allele frequency. It doesn't say the recessive trait. It's not talking about the gray squirrels. It's not talking about the blonde-haired people or the short pea plants. It says straight up the word allele, and it tells you it's the recessive. So that means you go to your allele frequencies formula, and you should know that the recessive allele frequency is Q. So in this question, you don't have to go through and go Q squared down to Q. They're telling you Q is 25%, and therefore Q is 0.25, and then you can work from there. You can find P, and you can find the genotypes that it asks you in the question. And again, this is a how many people question. Well, they've given you the population size. And so again, once you find how many have the free or unattached earlobes, then you times it by the number of people in the population. Okay, so allele frequency is different than recessive trait. Okay, so here's another example. Number 3, we've got 4% of the population could wiggle their ears. Well, this, it says straight up, is a recessive trait. So you know that is Q squared. And then here's a question that a lot of students get stuck with. We've got 1,000 tobacco seeds, and there's a 3-to-1 ratio of green to albino. So what does that mean? Think back to your genetics, and if you were doing a Punnett square and you had 3 that were green and 1 that was albino, well, you would say that 3/4 were green. 3/4 out of 1,000, okay, and that's 0.75. If there's 1 albino out of those 4 possible, 1 out of 4 is 0.25. Now, that albino, of course, is a recessive trait, right? So green is the dominant trait, and the albinos, that's the recessive. So it's just like doing a Punnett square. And so they're basically telling you that that is Q squared. And so once you know that that is Q squared, then you can work out your Q, and you can work out P, and then figure out how many are going to be heterozygous and what are the other genotype frequencies. Easy peasy. Okay, so keep going. What is some more questions that you might be given? How do you approach these questions? Same thing, read carefully. What are they giving me? Is it the allele frequency, or is it a homozygous recessive individual who has a recessive trait? So here again, the recessive allele, they're giving me Q for that one. Okay, 15% of a population shows me a recessive phenotype. Well, a phenotype is just another word for a trait. So in this question, they've given me homozygous recessive, that's Q squared. Okay, well, here's our last question, number 7. And in this question, we have ourselves a pedigree. So what the heck do we do here when we have a pedigree? Well, always, anytime you're given a pedigree, you have to ask yourself 2 questions. Is it going to be a dominant or recessive, or is it autosomal or X-linked? You've got to figure out the mode or the pattern of inheritance. So let's take a look here and see, well, here's an individual that's affected with the trait. How do I know that? Because they're shaded in. And so this individual, 3-2, is affected, yet neither parent is affected. So 2-1 and 2-2 are not affected. And I see that again here for this individual 2-5, and I see it again here for individual 3-9. And I also see it is going through this family, in this, and then not in this. So lots of evidence, like skipping generations, and the fact that we have an affected child but unaffected parents tells us that this is recessive. Then to look at and decide, is it autosomal or is it X-linked? Well, let's count up the proportion of males to females. So 1, 2, 3 males and 1 female. I wonder if this is X-linked. Well, let's take a look at a female who is affected, like this girl here, individual 2-5. Her dad is not affected. And if it is an X-linked, then her dad must be having an X with the affected allele on it in order for her to be affected, because mom would have to be a carrier. So looks as if this is probably autosomal, okay? And so not likely X-linked, and so as a result, I think that this is recessive, and autosomal is my mode of inheritance, okay? So once we figure out it is autosomal recessive, now we have to figure out how many individuals on the pedigree have this recessive trait. How many are shaded in, right? So basically, they've given us a recessive trait. They've given us the Q squared. So there's 1, 2, 3, 4 individuals out of how many? Well, count up how many individuals there are in the entire pedigree. And if you count it up, you will see there are 21 individuals in the entire pedigree. So, ta-da, Q squared, that's our homozygous recessive individuals, right? Recessive, you gotta have 2 copies of the recessive allele to have the recessive genotype. Once you have the recessive genotype, you get the recessive trait and you're shaded in. So this Q squared value, we can now figure out on our calculators, punch it in, 4 divided by 21, 0.1904, blah, blah, blah. And then this just becomes a regular question like we've been doing. From there, we find Q. From there, we find P. And then what's the question asking for? How many would be heterozygous? So they're looking for the 2PQ. And again, when you're asked how many, you have to times that by the number in the population. So this population, there are 21 individuals. And then it's also asking how many would be homozygous dominant. So how many? You find your P squared, that's the homozygous dominant, and times it by 21 individuals in the population. Okay, so that gives you an idea of how to do some of these questions, some really important tips on how do I recognize, is it a trait, is it an allele? So read carefully every question. How do I express my answer? Is it how many? Is it a percentage? And you should be golden. All right, that's it for now. Have a great rest of your day.